My dear students, we will speak today about the metal corrosion. What is the metal corrosion? The metal reacts with the environment. Metal reacts with the environment and corroded. There is a layer of oxide or metal hydrated oxide on the surface of the metal. This metal oxide is fragile, porous, and dissolving in water. So in this case, it enhances a very numerous galvanic cells inside the metal itself. The more active metal acts as anode, so it dissolves into the electrolyte and is corroded, and this anode is corroded. So we look here at this shape. It is corroded by the act of water, the salts, ions, and oxygen gas from air. It is corroded. There is a thin metal, a thin compound, hydroxide or oxide, is formed upon the surface of the metal. This oxide or hydroxide formed on the surface of the metal is fragile, porous, dissolved in water, so the galvanic cell process or the rusting process will continue, and the body of the ship is corroded quickly. Look here, there is iron, and on it a brown color. You see this brown color? This is ferric hydroxide or iron 3 hydroxide. So there are types of layers. Layers can be classified according to its composition, or the type of the layer, or its composition, into a layer of metal oxide or a layer of metal hydroxide, or what we call hydrated metal oxide, and the strength of the layer and its cohesion. It may be hard, non-porous layer adhering to the surface of the metal, or it may be a fragile, porous layer soluble in water. So if it is a hard, non-porous layer adhering to the surface of the metal, it acts as barrier between the metal surface and the environment. So it protects the metal from oxidation, or from being act as anode in a galvanic cell. So it protects it against corrosion. And if it is fragile, if it is porous and fragile, soluble in water, so it enhances the forming of galvanic cell, in which the anode will corrode it faster. So how can we know that this element is more vulnerable to the corrosion or to rusting, or not willing to rust or undergo rusting process? If the metal is very active, it will rust faster, it will be oxidized, it will release electron faster, its oxidation potential is higher. So we speak about the elements in the top levels, or in the top of the electromotive series. These elements lose its electron easily, be oxidized into oxides or hydroxides, and turn into layer. This metal turns into a layer upon the surface of it. This layer can be hydroxide or hydroxide. It may be non-porous hard layer, not dissolving in water, or it may be a fragile, porous, and soluble in water. So the active metals will corrode it faster, and the less active metals will not corrode it. Let's look at this. The existence of gold in nature individually, or gold is not corroded easily in normal conditions. In this case, gold is one of the elements lie at the bottom of the electromotive series of the elements. So its oxidation potential is very low. It cannot be oxidized or undergo or act as anode in the galvanic cell. So it cannot be oxidized, it cannot be dissolved in the electrolyte. There is no galvanic cell is formed, because gold has very low position in the electromotive series. It can take electron, but it cannot be oxidized. It acts as cathode in most cases it cannot act as anode, so it is not corroded. Gold cannot undergo a chemical reaction. Gold cannot replace any metal in its salt, so in this case gold is not corroded. Gold is not corroded, does not undergo any oxidation reaction. It is not oxidized easily. It is at the bottom of the electromotive series. Because of that, it exists in nature individually. Okay. Another case is aluminum. Aluminum rusting despite being of the metal that lie at the top of the electromotive series, as aluminum react with the environment, forming oxide layer. This oxide layer is non-porous layer of aluminum oxide and insoluble in water. So if it is non-porous, insoluble in water, hard, and stick to the surface of the metal, it protects it from further corrosion. So what is the mechanism of corrosion? Mechanism of corrosion: when the iron come to contact with water, some salts in water, and there is another metal or another element which is less active than iron. So anode is iron piece. Iron acts as an anode, so it is oxidized and go into the electrolyte, which is water and some salts in it, dissolved in the form of iron positive 2 or ferrous ions, and leaves electron in the same piece of iron. That means this piece of iron acts as anode and the outer wire in the same time. Okay, these electrons go to the cathode. What is the cathode? Another element which is, or another metal or non-metal which is less active than iron, and reduces the material of the cathode. So look at this. This is the overall reaction of the corrosion of iron. Two iron atoms in the solid form with a zero charge on it takes 3 water molecules and 3 atoms in the form of gas to form 2 ferric hydroxide or 2 molecules of iron 3 hydroxide. So this is the rusting layer. It is an hydrated form. Its color is brown. So let us take this process in some details. This process includes the reaction of the anode, oxidation of iron solid, 0 solid, into iron positive 2, and leaves 4 electrons. These 4 electrons go to the cathode from in the outer wire or in the iron piece, and reduces 2 atoms of oxygen in the form of gas, in the gaseous form, and 2 molecules of water to form 4 hydroxide ions. So the reaction of the anode is the oxidation of iron into iron positive 2 or ferrous, and the reaction of the cathode, 4 electrons taken from the oxidation of the anode, oxidation process which happened in the anode, to 2 molecules of water and 2 atoms of oxygen, 2 atoms of oxygen in the form of gas to form 4 hydroxide ions. So in this case, anode is the iron piece, and the electrolyte here is water, in which some salts ions are dissolved. So the anode reaction, as we have said, is iron oxidized into ferrous and 4 electrons released. So what happens in the cathode? These 4 electrons take 2 water molecules in the liquid form and 2 atoms of oxygen in the gaseous form to form 4 hydroxide ions. 2 ferrous ions arise from the reaction of the anode, and 4 hydroxide ion arises from the cathode part, then combination together to form ferrous hydroxide. Ferrous hydroxide or iron 2 hydroxide is oxidized easily, as we know that iron positive 3 is more stable than iron positive 2. Ferric is more stable than ferrous, as we have studied the properties of iron in the first chapter. Okay, then 2 ferrous hydroxide takes 1 atom of oxygen in the form of gas plus 1 molecule of water to form 2 ferric hydroxide. Ferric hydroxide is the rusting layer. So the overall reaction happen in the rusting is 2 iron solid, 3 molecules of water in the liquid form, 3 atoms of oxygen in the gaseous form to form 2 ferric hydroxide, the rusting layer. Okay, rusting in general is very slow process, but if there is some ions, a lot of ions inside the water, the rusting process becomes more faster, like the seawater, which contains a large amount of ions inside it, so it enhances the rusting process. So factors which cause metal corrosion. There are 2 factors causing metal corrosion: the metal itself, factors related to the metal itself, or factors related to the environment, surrounding environment. The factors which is related to the metal itself is the heterogeneity of alloys and the connection of metals with each other. The heterogeneity of alloys, because the metal which is produced industrially is not pure. It is impossible to prepare 100% pure metal. So in this case, local galvanic cells are formed where the more active metal acts as anode and it is corroded faster, and the less active metal or element is not corroded until after the more active element is corroded. Also, the connection we see here, the connection between 2 different metals. The more active metal is corroded first. Look at this. If we have points of welding metals together, copper with iron, aluminum with iron or with nickel, the more active metal acts as anode, so it is easily oxidized and dissolved in the electrolyte of this local galvanic cell using screws or rivets of another metal. This rivet is of metal. This rivet is of metal, or this screw is of metal, and the other surface composed of another metal. So the more active metal of the screw or the surface act as anode and it is corroded easily. So we now will study methods of protection. Methods of protection here composed of 2 methods, or two ways to protect the metal. The first way is to protect the metal by painting it with an organic material like oil, varnish, primer, such as minium. This method is not effective over the long time, as the layer itself, the organic layer, corroded or going away, or by the act of friction will go away from the surface of the metal. Then the metal will be corroded after that. But it is a way to protect the metal is painting the metal with an organic material like oil, varnish, or primer, or minium. Okay, another way, this is the way. The first way is to paint the surface of the metal with an organic material like oil, varnish, primer, like minium. The other method is covering the metal with another metal. So this other metal may be less active or more active. If it is less active, it is a cathodic protection. If it is more active, it is anodic protection. So cathodic protection, like covering iron by a tin layer, like this tuna cans made of iron covered with tin. So when scratching on the material of this cans, or of this can, happen, then a local galvanic cell is formed where the tin act as cathode and iron act as anode. So iron rusts faster than iron when it is not covered with tin. So this is a disadvantage of cathodic cover. Why? Because on scratching the cathodic cover, the metal to be protected like iron act as an anode, so it will corrode first, as it is the more active metal. The cathode layer, or the cathode layer which is supposed to protect the metal we want to protect or preserve, like tin, will not be corroded until after the main metal, which is iron, is corroded. So another way is to cover the metal with another more active metal. It is an anodic protection, like covering steel or iron with zinc or magnesium. So a local galvanic cell is formed, and magnesium or zinc is corroded faster than iron, or in the beginning first it corroded first, then iron. Okay, as magnesium or zinc act as an anode and iron act as a cathode. So magnesium, for example, will release electron, so it is oxidized instead of iron. So as it is oxidized instead of iron, it acts as an anodic cover or a sacrificing electrode. What is the sacrificing electrode? Sacrificing electrode is the anodic protection, or the anode, or the more active metal which is covered or protected another metal from corrosion. When it is in contact of another less active metal, it acts as an anode in this galvanic cell, and it will corrode faster, or it will corrode first, or instead of this less active metal. Like this iron pipe buried in the moist soil, so it is vulnerable to corrosion, and more inclined to be corroded. So we have to connect it with another more active anode. So it is connected with a magnesium, for example. So magnesium acts as an anode. So what has happened inside the anode, the anode of this cell? The reaction is the oxidation of magnesium from magnesium solid into magnesium positive 2, and leaves 2 electrons, and reacts these 2 electrons reduces 1 molecule of water and 1 atom in the form of gas of oxygen to form 2 hydroxide. Then the magnesium ion combines with hydroxide ion to form magnesium hydroxide. So it is oxidized instead of iron. It is corroded instead of iron. So it is called sacrificing electrode. So there is some notes we have to speak about. First, the rate of rusting process. The rate of rusting process of the preserved food cans increases when scratched. We know that the preserved food cans is a steel covered with iron. So on scratching, a local galvanic cell is formed where iron acts as cathode, iron acts as anode, and tin acts as cathode. So iron is more active, as iron is more active than tin. So iron acts as an anode, so it rusts faster. Okay. Anodic cover is more preferable than the cathodic cover in protection from rusting. Why? Because on scratching anodic cover, the cover which is more active than the main element or the main metal starts to be oxidized and corroded first. Then the metal that we want to protect is not corroded until all the anodic protection cover is corroded completely and consumed completely. But on scratching the cathodic cover, the metal that we want to protect corroded faster, or corroded first. The iron pipes buried in the moist soil are connected to zinc or magnesium plate. They are exposed to moisture, so we connect it with another more active metal, which is corroded instead of the iron. As its oxidation potential is higher, so the galvanic cell, which is formed from iron and magnesium or zinc, make the zinc or magnesium act as anode, so it is corroded instead of iron. Look at this example. The following figures represent two methods of protect iron from rusting. One of them is cathodic protection and the other is anodic protection. Which of these two metals, X or Y, represent zinc and which represent tin? We know that zinc is more active than tin, so this is zinc. This Y is zinc. Why? Because on scratching a local galvanic cell is formed and zinc oxidized first and iron is not oxidized. Iron is not oxidized and zinc is oxidized instead of iron, so it is an anodic protection. So the metal Y is tin, as when some scratching happens, then the iron oxidized or undergo oxidation process, and tin is less active than iron. So iron on scratching, iron plated or covered with a thin layer of tin, iron rusts first. This is a cathodic protection, as it is tin, the less active, it acts as cathode. This cover acts as cathode, and the iron acts as anode. So it is a protection, a cathodic protection or a cathodic cover. Here it is zinc. Zinc is oxidized faster than iron. Its oxidation potential is high. In this case, on scratching, a local galvanic cell is formed, and the more active metal, which is zinc, undergo oxidation process first, then iron. This is an anodic protection. We have 4 here. This is another example. The opposite figure represents an experiment which was performed in laboratory. It was observed after 1 month that water has risen to the highest level in tube WXYZ. So what is the idea of this example or this problem? The idea is, when the reaction is faster and iron go rusting, this gas inside will shrink, as this gas is consumed in the reaction of iron with the environment. Environment means this gas. So this is water, iron in the four tubes. What substance that make rusting or corrosion process is faster? The substance is oxygen more than nitrogen or hydrogen. Hydrogen and nitrogen do not make any sense in the rusting process or corrosion process. So air make iron rust and oxygen make iron rust. So air composed of 1/5 of it oxygen. Here 100% oxygen. So rusting process here in the Z tube is higher than that of nitrogen or hydrogen or just air, which contains only 20% oxygen. Okay, so the choice here is Z. The correct choice is Z. Oxygen reacts faster with iron metal with water and some salts in water, so make this oxygen consumed and the volume of oxygen decreases, so the water rises up in the tube. Let's take another example. The following statements exhibit the conditions. The following statements exhibit the conditions of preserving 4 iron plates. So plate 1 covered with copper, plate 1 covered with copper sheet and exposed to humidity. So copper sheet will protect it to some extent. Exposed to humidity, yes, copper sheet will act as a cathodic protection. It will not corrode, the iron will not corrode it, or steel cannot corrode it, except that except there is a scratching in the copper sheet, so that iron act as anode and copper sheet act as cathode. But this will happen when scratching of copper. So it is a kind of protection of the iron. The second, placed in open vessel containing dry agent. So dry agent will protect it against rusting or corrosion. Exposed to air and humidity, okay, but there is some protection here, drying agent, which absorb the water vapor from air. Second plate, placed in the sea beach, where there is oxygen, there is air, there is water, which contains a lot of ions and humidity, so it is not preserved. Plate number 4, placed in a closed vessel and exposed to humidity only. It is preserved to some extent, as it is preserved in a closed vessel, but it is exposed to humidity. So each plate would be corroded at faster rate. I think you know it. It is the one that placed on the sea beach and exposed to air and humidity. Another example, a bike is left in the outdoor for months. Then rust marks were noticed on some of its parts. All the following can decrease the rate of rusting reaction, except first, A, removing rust and painting its position with medium. Yes, it is a kind of protection. It is an organic, it is a protection happen when we plate or paint the metal with organic compound. Okay, it is a kind of preserving against corrosion. Second, B, removing the rust and moving the bike to a dry place. Dry place is a kind of preserving, so there is no humidity, there is no ions, and to some extent there is no galvanic cell. Removing rust and wiping its possession with clean cloth, wetted or wet with water. Wet with water means water includes ions, oxygen from air, so it will enhance the forming of local galvanic cell, which make the corrosion process faster. So removing rust and wiping its possession with a clean cloth wetted with oil. Oil is not dissolved in water, so it will protect to some extent. There is no galvanic cells for a short time, but it is a kind of preservation to paint it or wipe it with a cloth wetted with oil. So which one of them will rust faster? Okay, it is the removing the rust and wiping its possession with a clean cloth wet with water. This is the correct answer, as wiping it with water will enhance the formation of local galvanic cells and enhance or increase the rate of corrosion. Another example, cathodic protection of a piece of iron is achieved by, look at this, cathodic is painting or covering the metal that want to protect with another less active metal. So first choice, painting with primer. This is organic, this is not correct, this is not a metal. Covering it with lead or copper. Yes, copper or lead is less active than iron, so it is considered as a cathodic protection. Painting with varnish, it is an organic compound, it is not a metal. Covering it with magnesium or lead, This is an anodic protection or anodic cover where it acts as a sacrificing electrode. This is not the cathodic cover. So the correct answer here is B, covering the iron with lead or copper, as copper or lead is less active and they act as cathode, so they are considered as cathodic protection. Look at this. According to the opposite figure, which of the following is correct? If the metal X is zinc, then iron acts as anode. Now iron and zinc, which is more active? Of course zinc. So zinc acts as an anode, not iron, so it is not correct. If the metal X is copper, metal X here is copper, so then it will act as cathodic cover. The cover means to cover all the metal, so it is not covering all the metal, it covers a part of it, just a part of it. This part only is a cover, so it is not considered as a cathodic protection, okay, or it is not considered as a cover at all, because a part of iron is not covered by the copper. 3 or C, it is probable that this reaction occurs. What is this reaction? A cathodic reaction of rust. 4 electrons comes from the oxidation of the anode, takes 2 atoms of oxygen in the form of gas and 2 water molecules to form hydroxide ions. So it will happen. It is the reaction of rusting, and it really will happen, and this is the correct answer. This is the correct answer, C. Another question. The following figures show 2 experiments, 1 and 2. A rod of magnesium, a rod of iron dipped in a zinc nitrate solution. So what will happen to this zinc nitrate solution, or what will happen to the 2 electrodes when they are dipped in a zinc solution, whether magnesium is in contact with iron or not? So let's read. Which of the following determines the metal whose mass would decrease over time? Decrease over time. What is the more, or who is the more active metal? Magnesium, iron, zinc. The correct arrangement is that magnesium from 2A elements is more active than both iron and zinc is more active than iron. So magnesium will replace zinc in the zinc nitrate solution, and zinc will precipitate in both cases. Iron is less active than zinc, then the mass of iron is stable, constant. It will not dissolve in zinc nitrate solution, as iron cannot replace zinc. It is less active than zinc. Its oxidation potential is 0.44 volt. It is less than the oxidation potential of zinc, which is 0.76 volt. So magnesium will dissolve in this solution in this case, and in the other case magnesium also will dissolve in the solution of zinc in both cases, as magnesium is more active than zinc in both cases. So magnesium will dissolve here and dissolve here in both cases. Iron is less active than zinc. So iron cannot replace zinc in its salt solution. So the first choice, magnesium in experiment 1 only, will decrease its mass. No, the magnesium in both cases. Iron in experiment 2, iron is less active than zinc, so it cannot replace zinc. It cannot be oxidized in contact with zinc, so it will not dissolve in the solution, so the mass of iron will not decrease. Iron in both experiments 1 and 2, iron cannot be corroded as magnesium and zinc is more active than iron. So iron will not act as an anode. The material which act as anode in both cases is magnesium. So magnesium in both experiments, yes, the mass of magnesium in both experiments will decrease, and this is the correct answer. Here the correct answer is D. Magnesium in both cases or in both experiments its mass will decrease. At this point, so there is another example. Okay, two similar steel reservoirs X and Y buried in the moist soil. A piece of magnesium is connected to X and a piece of copper connected to Y, as in the opposite figure. This is iron. This is iron reservoir connected to magnesium, and iron reservoir Y connected to copper. So what is the question? What are the oxidation reaction occurring in both cases, which are represented by the figure 1 and 2? The figure 1 and figure 2. Let's look at the choices. In figure 1, magnesium is more active than iron, so it will be oxidized. So the oxidation of magnesium is correct in the first case, so these cases are wrong. Iron is oxidized is wrong. Magnesium is oxidized in the first case. In the second figure, iron and copper. Iron is more active, so it will be oxidized in the first place, or oxidized first prior to the copper oxidation, as the oxidation of the iron potential is higher than the oxidation of the copper. In this case, in the second figure, iron will be oxidized. So here magnesium in the first case correct and iron in the second figure will be oxidized. So the correct answer is A. I hope that you understand what the explanation. Excuse me for the lip slip in this session. Afterward, we will explain the electrolytic cells. Thank you.